Year 7, let's have a look at the solution to the probability analysis task. Question 1, the rolling of 2 dice, plural of die, 1 die, 2 dice. Here's your first die, whoops, go to here, first die is this one here, and here's your second die here. So you roll it out, the first one is 1, the second one is 1, you get a total of 2. If the first one is 2 and the second one is 1, you get a total of 3. If the first die is 3 and the second one is 1, then you get a total of 4, and so on. You've got 6 here, then you've got another 6 across here, another 6 in this row, so you have a total of 36 outcomes. Another way of looking at this is, here's your, let's use a different colour, here's your first die, here's your second die. So you roll your first die and you get a 1, second die is a 1, you get a total of 2. First die is a 2 and you get it, and the second one's a 1, you get a total of 3, and so on. So if you look through here, 7 has the highest chance of occurring and 2 has the least chance, along with 12. There's 2 for 11, there's 2 for 3, there's 3 for 4, and there's 3 for 10, and so on until you get to 7, which has got 1, 2, 3, 4, 5, 6. 1 in 6 chance. So that's just another way of looking at the same thing. So total outcomes 36. The sum of 2 you can only get once. 1 in 36. The formula is already written, so you just write there. Even number, it has to be half, 18 in 36, so it's 1 in 2. Probability of a sum less than 6, the point always points to the lesser number or fewer or smaller number, 10 in 36, which reduces down to 5 in 18. Sum of greater than 10, which will be 11 and 12. There's 2 of 11 and 1 of 12, so that's 3, and that reduced 3 in 36 reduces down to 1 in 12. The probability of the sum of 11 is 1 here and 1 here, so that's 2 in 36, which reduces down to 1 in 18. And we always reduce it down. Now here I've rolled a die. Second question was to roll a die 36 times, and I did that. 1 came up 6 times. I kept a tally in this column here. This is a frequency table, and a relative frequency table, like I said, has a 4th column when you divide 6 over 36 and put it into a relative frequency. Same thing, desired outcomes or desired frequencies over total frequencies. But this is a basic frequency table with three columns. Now, how many times was an even number rolled? That's a 6, that's a 4 and a 2. You add those up, you get 18. To get 4 marks in a probability question, proper probability question, you have to show the formula. The probability with the event in a bracket, desired outcomes over total outcomes. So, an even number, probability, even number in brackets, 18 out of 36, 1 in 2. How many times did you roll a number 1? 6 times. There it is there, 6 times. What's the experimental probability of rolling the number 1 in your experiment? Probability of 1, 6 in 36, which is 1 in 6. And the probability of rolling a number greater than 4, which is 5 or 6, and if you have a look at both of them, 5 or 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 5 or 6, probability is that, let's check, probability of a number greater than 4, you've got 13, 5 and 6 occurs 13 times. You can't reduce that down. Here's a survey about eye colour in year 7s. Blue, brown, green and hazel, when you add them up, there was 80. Probability of choosing a blue-eyed student. Blue is 11 in 80. Probability, blue eyes in a bracket, the event must be in a bracket, is 11 in 80. Probability of choosing a hazel-eyed, hazel, 8. 8 in 80, that reduces down to 1 in 10. There's a 1 in 10 chance of choosing a student with hazel eyes. What's the experimental probability that a student has blue or green? So blue or green, blue is 11, green is 3, that's 14 in total, 14 in 80. Probability of blue or green, 14 in 80 reduces down to 7 in 40. Probability of not green or hazel. Probability, the event in a bracket, and it's 69 because there's 11 that are, so there must be 69 that are not. 69 in 80, can't reduce that down. If the distribution of eye colour is similar to across the year level, and there's 640 students, how many would you be expected to have brown eyes? So 8 times 80 gives you 640, therefore 58 who had them here, brown eyes, 58, that's multiplied by 8 as well, you get 464. So therefore 464 would be expected to have brown eyes. Now here in Aussie Rules, there's a team, Hawthorn, Collingwood and Melbourne. What's the probability? These are people who support. Probability of selecting a person who supports Hawthorn or Melbourne. So Hawthorn and Melbourne, 17 plus 21. Probability, the event is Hawthorn or Melbourne. 38 in 70 reduces down to 19 in 35. To get the full marks, that's what you had to show. What's the probability of selecting a person who supports Collingwood? 32 in 70. Probability, Collingwood is the event. 32 in 70 reduces down to 16 in 35. To get the full marks, you have to have the probability formula. If a larger sample of 1,400 people were surveyed, how many would you expect to support Collingwood, which is the only team to support, of course, the world's best football team? Now, when you multiply 70 by 20, or you divide 1,400 by 70, you get 20. So you multiplied 70 by 20 to get 1,400. Then you multiply the number who support Collingwood by 20, and that's 640. Therefore, 640 people you would expect to support Collingwood. And notice I've answered the question. Last line of clear working out is answering the question. And here you could have done it this way, 16 out of 35 times 1,400. And that will give you the amount as well. You cross cancel from here to here and from here to here, and that's what you get. Same answer, 640. So there you go. That's the probability analysis task. Thanks.